Today, I want to work with graphing sine and cosine as a function. And I'm going to be presenting it in a slightly different way. We could figure out how to graph sine using our unit circle values. Sine is what? The x or the y? Well, because we're trying to, just kidding. So if sine is the y value and I start at 0 degrees here, what's the y value at 0 degrees? 0. So my sine function starts at 0. And how long does it take before it cycles back and begins the second wrap? 2 pi. So I know that at the end, at 2 pi, it's also back at 0. Now I'd like to just jump here to the second over here. What is the radian measure for over here? Pi. And what is the y value at this point? Also 0. So in other words, halfway to the end here, the sine function comes back to another x-intercept. As I work my way back from the beginning, 0, and I move up here to pi over 2, what's my y value there? 1. And that's the maximum value. Between pi and 0, halfway between, reaches a maximum value of 1. What about when I come down here to 3 pi over 2? 3 pi over 2. Negative 1. So I reach my minimum value, my local minimum, at negative 1. And this is the curve of sine as a parent function. So this is our primary function in sine. Quiet, please. What I'd like to ask you guys is to think about it this way, broken up into 4 chunks. It'll make your life much easier. Last night in your homework, what you guys were working with was this idea of what if the period changes or the amplitude changes? And so, for instance, you might have had a function like f of x is equal to the sine of 2x. What does that do to the period? Period is normally 2 pi, but if this is adjusting that period, we divide that by this number. So we take 2 pi divided by 2, which makes it pi. Now, if I were graphing this, all I'd say is, okay, I'm going to graph the sine function with a period of pi. What that would look like is I'd say, okay, it's sine. Sine starts at 0 and it ends at 0. But where is that end? Because with pi as the period, I'm expecting it to end at pi. And then halfway in between, what's its value? You're right, the x value is pi halves. What would be the y value of the function? 0. Remember here we had it starts at 0, it ends at 0, halfway between is at 0. And then at this quarter point, halfway between this and this, what's the y value? 1. And halfway between these two, what's the y value? Negative 1. So this is the function. Like our transformations, what we see is it happens twice as fast. Zing, right? If I did a second period, it would complete 2 full cycles in the 2 pi period. Now, when scaling these axes, I'd like you to think about fractions. It was easy enough to say if this is pi and this is 0, I can find this x value by just saying what's halfway to pi? Well, that's pi over 2. And you could do the same thing here. If we know that this is the midpoint between 0 and pi over 2, what's this value? Pi over 4. This one's harder for people. And so I'd like to suggest from your geometry knowledge, you know that the midpoint between 2 points is just the average of the points. So if I want to find this value, the x value here, I would just say pi over 2 plus pi over 2. Well, this is the same as pi over 2 plus 2 pi over 2 over 2, which is 3 pi over 2 over 2, which is 3 pi over 2 times 1/2, which is 3 pi over 4. So this x value is 3 pi over 4. Does that make sense? Even if it's some crazy thing. Let's say that we're doing f of x equals sine of 7x. In terms of period, that's going to be as crazy as we get. What's our period? 2 pi over 7. Those of you that hate fractions are twitching right now. But let's do it the same way. Where does sine start? 0, 0. I'm going to even draw this over here. I know it's going to end there, and it's going to have a middle point there, and it's going to have a high point here, and it's going to have a low point here. That's my graph. All I have to do is scale it. What's the x value at the end here? 2 pi sevenths. I went all the way to the end of one period. What's my halfway point? What's half of 2 pi sevenths? 1 pi sevenths. Because you can take half of something by either halving the numerator or doubling the denominator. I could have made this 2 pi 14ths, which reduces to pi sevenths. So what would be this midpoint here? Instead of pi sevenths, it'd be pi 14ths. Or you could have said, I want to find the average between 0 and pi over 7. So that's the same as pi over 7 times 1/2, which is pi over 14. That's what that's going to be. Please take a moment to find this missing number. Go. Between pi sevenths and 2 pi sevenths. I see some smug looks over there. What do you got? 3 pi 14ths. Beautiful. And pro tip, we broke this up into even fourths. How big is this gap from 0 to pi over 14? Pi over 14. So this is 1 pi 14th. This is 2 pi 14ths. This is 3 pi 14ths. This is 4 pi 14ths. It's broken up into even fourths. Now, how does this change when we put a lead coefficient out front? What if I have like f of x equals 2 times sine of 1/2 x? What's my starting point? 0, 0. Here's my ending point. Here's my middle point. Here's my high. Here's my low. What's this value? So the period should be 2 pi over 1/2, which is 2 pi times 2 over 1, which is 4 pi. If that's 4 pi, how big is this one? And if that's 2 pi, how big is this one? 1 pi, 2 pi, 3 pi, 4, 4 pi, 5 pi, 6 pi more. So this gives me the function, but now what does this 2 out front do? It's the amplitude. Instead of going to a high of 1, I'm just going to go to a high of 1 times this, whatever this thing is. Times 2, this is supposed to be at -1, multiplied by 2 gives me -2. How you feeling? 5, this is ridiculously easy. 3, I'm cautiously optimistic. 1, I'm getting a great nap. Okay, good. So what's different about this one? And that +4 at the end of a function, what does that represent? A vertical shift. So this is still a sine function, but instead of us playing with like 0, 0, 0, high, low, we need to have a new midline at 4. So I'm going to just draw my new midline here at 4. The whole thing is moved up to 4. That's a midline of f of x equals 4. And now it's otherwise a sine function. Where does sine function begin? 0. What's my period? Well, it'd be 2 pi divided by whatever's in front of the x, which is a 1. So this is just regular. This is 2 pi. So I'll go over to 2 pi and finish my function. Halfway between is at pi. What happens here at halfway between pi and 0? That's pi over 2. What should it be? Up. Because the amplitude is 1 here, it's only going to go up 1 unit. And then at this 3 pi halves, excuse me, it's going to be down 1 unit. And that doesn't use up the space very well. So please consider recognizing, remember how I said this is broken up into even fourths? It goes from a x-intercept, a 0, up to a high, to an x-intercept, to a low, to a high. So if I'm going this way, what's this next point 2 spaces over going to be? A low. 2 spaces over, back up to a mid. 2 spaces over, back up to a high. 2 spaces over, back up to a mid. Now I've got 2 cycles or 2 periods shown on this graph. Now, 2 things have changed about this one. What 2 things? It's no longer sine, it's cosine. And it's got this horizontal shift that's actually called a phase shift. We didn't have one here, so that should have been 0. This was +4. So in this case, we've got a phase shift. What do you think this is moving, left or right? Good. Left. Pi units. What's the period going to be for this one? It's going to be 2 pi divided by 1, which is still 2 pi. Good. What's the amplitude? 2. Good. Does it have a vertical shift? Nope. So what's the midline? 0. Good. Stays where it normally is. F of x equals 0. Now, the difference here is this isn't sine. This is cosine. So let's go off on a tangent for a second. Get it? Sorry. So what if we said f of x equals cosine of x? Let's go back to how we create this. When I start cosine at 0, what's my value? Because now we're looking at the x values. It's 1. So I start up here at a max. And then when I go all the way around to a cycle, I finish also at 1. When I go halfway around a pi, what's my new value? -1. So in other words, halfway here, I'm going to be at a negative. And then at points in between, I get my zeros. So the cosine has the same shape, but it's really kind of shifted, isn't it? It's like it's the sine curve shoved over to the right, pi over 2. Does that look familiar to anyone? There's a little game in here, right? Because this would really be sine of negative pi, positive pi over 2 minus theta. And so because of our odd functions, this becomes negative sine of pi over 2 minus theta equals cosine x. So they're not exactly the same. The cosine would actually be, oh, because I moved this to the right, didn't I? This says that it'd be cosine moved to the right. But if I move cosine to the right, that would be this one. So that would have to suffer a reflection over the x-axis. It's this. That's the same as a cosine. Okay, anyway. So the cosine is the exact same idea, except that you start at 1, the max. Finish the cycle at 1, go to a min, zeros in between. So let's come back to this one. This has a phase shift to the left pi. So I'm going to move over here to this, and I'm just going to visualize that this is now my origin spot right here. What do I do at the beginning of cosine, at the origin? Is it a max, a 0, or a minimum? It's a max. It starts at a max. So here at my new origin spot, I've got an amplitude of 2, so I'm going to go up to 2. my period is 2 pi. So from here, I'm going to go 1 pi, 2 pi, and I know it cycles right back. It's again at a max. Halfway between those, what do I have? Minimum. So at the 0, I'm going to have a minimum. And halfway between those, I got to cross over the x-axis here. So there's my function. If I wanted to extend it to show more periods, again, I'd say it looks like I'm going 2 spaces for each of my important quarters. So if I went 2 spaces to the left, that would take me back down to the midline. 2 spaces more would take me back down to a relative minimum. 2 spaces more would be back down to a midline. 2 spaces more would take me down there. And this is actually kind of 2 cycles of negative cosine, isn't it? It's flipped over the x-axis, but it's still 2 cycles. It's 2 full periods of cosine. Would you guys please try number 4 yourselves now? Go. Okay, so here's what most people struggle with these. What sequence should you do them in? I think it's best to work right to left. So first I'll do this, -1. That's a vertical shift, down 1. That tells me my midline is now f of x equals -1. It's a vertical shift, down 1. Then I'd say, okay, this is my phase shift. I need to go to the right, pi over 2. So this is like my new center point here. I've got a 1/2 here, suggesting that my period is going to be 2 pi divided by 1/2, which is 2 pi times 2, which is 4 pi. My amplitude in front is a 1. Okay, I've now applied all these things. Now I just have to graph it. This is my new starting point. For cosine, do I expect it to start at a high, a mid, or a low? High. So from here, I expect it to be at a high value, which would be 1 unit up because my amplitude's 1. Then I'd want to go 4 pi more to get to the next cycle, but I can't fit 4 pi. So think about a cosine. If I can't go from a high to a high as a full cycle, what if I did a half cycle? I'd go from a high to a low. So I'm going to go from here, I'm going to go half of a full cycle. I'm going to go 2 pi, 1 pi, 2 pi, and that's going to be a low. Halfway between those, I expect to have a midline. And notice what I'm showing here is 1, 2, 3, 4, 1, 2, 3, 4. Every 4 spaces, 1, 2, 3, 4, is one of those critical values. So if this is at a high, next one here will be a mid. 1, 2, 3, 4. Next one will be a low. 1, 2, 3, 4. Next one will be a mid. So this is my graph. How'd we do? 5, I got it perfect. 3, I got it really close, and I could get it next time. 1, I drew a puppy dog. Okay, good. Any questions? Yeah. I didn't until I tried to apply one period. I started with here, and then I said, I need to go a full period. I can't. So I'm going to go a half period. And if 4 pi is a full period, that means 2 pi is a half period. Notice that the way this is scaled, 1, 2, 3, 4 pi for 1, 1, 2, 3, another 4 pi for 2. So I need to move 8 units over from this, right? Because it's 4 for each of them. So I moved 1, 2, 3, 4, 5, 6, 7, 8. And then that tells me that if it's 8 for half a cycle, it's 4 for a quarter cycle. All right. What's your confidence with doing graphing of sine and cosines? 5, I got all of them. 3, I'm going to be a star as soon as I practice this a little bit more. 1, I'm going to watch this video and hope it makes sense to me. Okay, good. Ready for the twist? We are not going to do tangents today. We'll do that another day. But we are going to do what's called reciprocals. You remember the reciprocals? Cosecant is the reciprocal of what? Sine. So this is the same as 1 over the sine of x. Agreed? Cosecant's the same as 1 over sine. So please watch as I graph the sine. For the cosecant, I'm going to graph sine. Sine starts at what? 0, 0. And if I go all the way to the end of a period to 2 pi, it's again at 0, 0. Halfway between, please be quiet, will be 0, 0 again. Halfway between those two, I expect to have a maximum. Halfway between those two, I expect to have a minimum. So this is my sine curve that I've drawn here, right? Now, this is the reciprocal of sine. What is the reciprocal of 0? What's 1 over 0? An asymptote. It's undefined. So I'm going to have an asymptote running right down my y-axis. Here again at pi, I'm going to have another asymptote because my sine function is 0 there. At 2 pi, I'm going to have another asymptote. Now let's look at our relative mins and max. If this value is 1, what's the reciprocal of 1? No, what's 1 over 1? 1, stays 1. What's the reciprocal of negative 1? Still negative 1. So these values don't change. Do you agree that somewhere in here, I'm reaching a y value of 1/2? We don't know exactly where, but somewhere in here I am. Turns out to be 30 degrees, but this value has a value of 1/2 for the sine, which means the cosecant at that will be what? 2. So up here it's 2. It reaches another half here, which means it's up to a -2 or a +2 here. When I come over here, there's some point in here that's a -1/2, which means that's a -2. So all you have to do is you graph the sine, and every place that you have a 0 becomes an asymptote. Every place you have a maximum stays that point, minimum stay that point, and then you just draw these little U's in between the asymptotes. Yeah. Not today. You can cross that out. For secant, how do we graph that? Cosine with the same rules. So let's do this one. Go down to number 1 here. What's the parent function, quote unquote, that we're going to start with? Sine or cosine? Sine. So I'm just going to think about sine for a second, which means I'm going to start at, let's see, I don't have any vertical shift. I don't have any phase shift. I don't have any period adjustments. All I've got is an amplitude. So my period's still 2 pi. I'm just going to write in here to help myself. My amplitude is 3 over 2. I start at 0, 0. Sine starts at 0. After 2 pi, it's at 0. At pi, it's at 0. Halfway between these two, it's going to be at its maximum, which is 3/2. Halfway between these two, pi and 2 pi, it's going to be at a minimum, which is -3/2. So I don't even need to connect these things. I don't need this swoopy part of my sine. I just need these 5 points. For my cosecant curve, what happens at sine equals 0? What's the reciprocal of 0? Undefined. That's a vertical asymptote. At pi, I have another 0, so that's also a vertical asymptote. At 2 pi, I have another 0, so that makes a third vertical asymptote. At my relative maximum here, I'm just going to leave it right there. Because if I looked at the sine value being 1, but now it's cosecant, so that's the reciprocal, which is 1, and then I applied the amplitude of 3 over 2, it would still be 3 over 2. So all I do is from this point, I show myself graphing parabola-looking things. They're not actually parabolas, of course. And what if I were to say, give me 2 full periods? This is the equivalent of 1 period. How can I move to the left and extrapolate to see another period? 1, 2, 3, 4. Looks like it's 4 spaces between each of the asymptotes. So 1, 2, 3, 4. There should be an asymptote there. 1, 2, 3, 4. There should be an asymptote there. And the sine is cyclical. It goes up, middle, down, middle. So if I went up, middle, this should be a down. Amplitude is 3/2, so that's negative 3/2. Back up to middle, up to 3/2. And so I would just see these as my second period. Reasonable? Okay. Period for cosecant and secant is what? What do you expect it is? It's the same as sine and cosine, isn't it? So it's 2 pi. We'll talk about cotangent later. Turns out it's pi if you want to put that in there. Happens twice as fast. Would you please now give yourselves a nice, clean parent function of cosecant and secant? You can leave this tangent undone for now, but don't cross it out because it's a nice little grid that we'll use on a future day when we work on tangent. All right, your job is to finish the cosecant and secant examples here, and then the rest of the problems that we haven't done other than the tangent ones. You can skip the tangent ones. That's your homework number 37.